Hello and welcome to another episode of PEEPanEIP, an EIP dedicated series where we discuss an Ethereum improvement proposal and understand why that is important for Ethereum blockchain. I'm your host Pooja Ranjan, and today we are going to talk about EIP 1559 fee market change for Ethereum 1.0 chain. EIP 1559 is a standard track code proposal in draft status. So generally in this show, we invite the author of a proposal to get an overview and answer the questions that we receive from community. But EIP 1559 is one of a kind proposal. So for this episode, we have invited the champion of the proposal, Tim Beiko, who is heavily engaged in community interaction for this proposal. We are also joined by William Schwab from Ethereum Catalyst team and Dragon Rakita from the Open Ethereum team. Welcome, Tim. We already know you as a cat herder, but for our audiences, if you can please give us a quick intro before we dive into the proposal.
Sure. My name is Tim Beiko. I'm a senior product manager working at Consensus. There, my work is on the protocol team. So we build the ETH1 client called Hyperledger Besu. And as part of that work, the Besu team has been leading the implementation of EIP-1559. And this is what I'll talk about today. So to give a bit of background on the EIP itself and share where we're at and what the next steps are for 1559. So starting with the overview, what is EIP 1559? At a high level, 1559 is an EIP that was put forward by Vitalik in 2019, and it has two main goals. The first is to make the Ethereum fee market a bit more efficient, and the second one is to improve the transaction sending UX. So at a high level, what it does is, first of all, it'll hard code the minimum fee a transaction needs to pay to be valid in the block header. And this is what we call the base fee. So any block will then be able to specify how much a transaction needs to pay at a minimum to be valid in that block. And the way that the base fee is set is by looking at how full the blocks are, or more specifically, how full the previous block was. And then in order for this base fee to actually be tamper-proof and to not be changed upwards or downwards by miners, we have to burn that part of the transaction fee because otherwise we could have off-chain agreements happening or just miners stuffing blocks into transactions to get the fee back and then raise the base fee for everyone else. So that means we end up burning the base fee. And to give a bit more detail on how we actually go about setting that base fee is that under 1559, we allow blocks to be up to 200% full. So what that means is if blocks are more than 100% full, considering the gas limit, then we start raising the base fee so that we kind of increase it to match demand. And then if blocks are less than 100% full, we lower the base fee. And that's how we were able to stabilize it on the network. And what's nice about this is that this provides us a bit of extra capacity on chain for when there's rapid spikes in demands on the network. So if you're interested in just like learning more about 1559 and the background and whatnot, there's three things I think make sense to look at. The first is the EIP itself. This has the technical specification for 1559. So if you're coming at it more from like an implementer or like a developer perspective, that's probably the best place to start. The second is Tim Roughgarden's economic analysis of the EIP. So Tim Roughgarden is a computer science and game theory professor from Columbia, and he's put together a really extensive analysis of the EIP. So reading through that will give you context from a more from the fee market's perspective. And finally, if you're interested in more, I guess, the project management aspect of it and how it's coming along, I've been putting together updates that I've shared on HackMD. So you can read those and see how things are coming along week by week. So looking at 1559 in more detail, we mentioned earlier that we are adding this base fee field to the block header. So just trying to go over all the changes, we'll be doing both the block header and transaction format. The base fee goes in the block header and specifies the minimum fee a transaction needs to pay to be processed. And then on the transaction side, there's two new fields that we will add. The first is called gas premium, which represents a tip to the miner. So like we mentioned earlier, the base fee part of the transaction fee gets burnt. And so if we only had the base fee and burned that, miners wouldn't have any motivation to not mine empty blocks and to not process transactions. So in order to circumvent that, we add a gas premium, which goes directly to the miner. And then because the base fee can move from block to block, we let the transaction specify the fee cap, which means the maximum it's willing to pay for its entire transaction fee. So that means that if the base fee goes up between a block and the next one, you have a bit of leeway with regards to how much you'll be paying. And then you can set a fee cap pretty high because whatever the difference is between the fee cap and then the base fee and the gas premium gets refunded to you. So if you set, say, a fee cap of like, I don't know, 1 ETH, and then your base fee is like 10 GUI and your gas premium is 1 GUI, everything that's not like that 11 GUI that you've paid will get refunded back to you. And one thing that's nice about this is we can actually keep supporting legacy transactions on the network after 1559 by interpreting them as 1559 transactions. And the way we do that is we set the fee cap to the gas price of the transaction, and we set the gas premium or the tip to the gas price minus the base fee. And what this means is that legacy transactions are still valid on the network, but they won't be getting that refund that 1559 style transactions get when they use the fee cap. Second, it's worth looking at this idea of 200% full blocks in more detail. And more specifically, you know, if we can do 200% full blocks under 1559, why can't we just do them all the time and double the block gas limit? And the reason for that is that the network can't actually handle, you know, twice as big blocks forever. But under 1559, because of the rate at which the base fee goes up, it means we'll only ever have very short periods of times where blocks are 200% full. And that is hopefully something the network is able to handle. So to make this a bit more concrete, right now, the way the base fee updates is that if a block is 200% full, it'll increase by 12.5%. In the next block. So at that rate, it would take roughly 20 blocks for gas prices to go up 10x, 40 blocks for them to go up 100x, and 60 blocks to go up 1000x. And 60 blocks is roughly 15 minutes on the network. And to give you an idea of scale, in like all of Ethereum's history, we've seen basically 1000x range in gas prices. So that means that, you know, in 15 or at the very least 20 minutes, we've kind of provided an increase in fees that's, you know, bigger than all of Ethereum's history. So that means we won't get twice 200% full blocks for longer than that. And then what happens is once the base fee has risen high enough to process all of the new demand, users won't want to pay that. So that will result in blocks not being full anymore, meaning that the base fee will start dropping again all the way until blocks are 100% full again. And yeah, so that means that if you have like a large spike in demand, so say a new DeFi pool, ICOs or whatnot, the fees will spike up really quick. And then once those high paying transactions have been processed, they'll lower back to where they were originally. And one thing that's also nice about these 200% full blocks is that if we have blocks that are, you know, 100% full on average, like they are today, we kind of have this extra 100% of capacity that we can use. And that means that the average transaction always gets included in the next block by paying the base fee and maybe a small tip, which is really nice because right now, you know, you look at Ethereum and it's very hard to predict when you'll be included on the chain and how long it will be. So under 1559, we'll make kind of including transactions in the next block or the next couple blocks much easier and reduce the amount of overpayment that requires because we'll have the base fee directly inside the protocol. And the last big part of 1559 is the fee burning. So we touched on this a bit in the first slide, but in order for 1559 to work, you can't have the base fee go to the miner of the block. And there's two reasons for that. The first is that if we don't burn the base fee, the miners can then fill blocks with their own transactions and that'll push the base fee up. but then they'd get the base fee back, so they don't mine for their own transaction fees, and everybody else on the network would have to then pay those high fees. So that would not be great. And then the second thing that could happen is that users could pay miners off-chain or on-chain with another token than Ether to include their transactions with a lower transaction fee. Whereas if they do that after 1559, the miner still has to go and buy Ether to pay for that transaction fee because it gets burned. So it kind of cements Ether's role as the only asset you can use to pay transaction fees on the network. And then obviously, if we just burnt all of the miner revenue, they wouldn't have an incentive to process transactions at all. So this is why we have the gas premium. And it's worth noting that the gas premium is not only useful for miners to keep transactions, but if we have periods where there's a lot of demand and you absolutely want to be in the next block and blocks are already 200% full, then you can pay a large premium to be included quicker. Or if you have a transaction that has like a really high value and a very specific time at which it can be executed, like for example, a DeFi arbitrage trade, then you can also put a large tip on that transaction to signal to the miner that you wanted to include in as soon as possible. And then one last thing that's nice about the fee burning is that it creates a positive feedback loop between the network usage and the value of the network, because it means that as more and more people want to use Ethereum, the demand for block space goes up, which raises the base fee, which results in more Ether burned in every single transaction. So it's kind of like almost a share buyback for Ether holders, where as more people are using the network under 1559, more Ether gets burnt, and that reduces the supply, which has a positive impact on the network value. And just before we move on, there's two misconceptions about 1559 I wanted to make sure I took the time to clear up. The first is that 1559 will lower gas prices. This is not 100% true. So it'll make gas prices easier to estimate, which leads to gas prices within, say, a single block to be lower, because right now people tend to overbid for that space, but it won't cause, like, say, a 10x reduction in gas prices, because gas price is a function of supply and demand. And as long as the block space we have available, which is the supply, is fixed, if demand is high, then gas prices will be high. So 1559 really isn't like a primarily intended to reduce gas prices. And then the second misconception that comes up a lot is that 1559 will make Ether deflationary. And this is really only true if the transaction fees from the base fee are much higher than the block reward. And it's worth pointing out that, you know, until recently, the block reward had almost always been higher than the transaction fees, and that the tip doesn't contribute to the supply reduction, right? So if we had a world where the base fee was moderately high, but then the tips were actually quite high most of the time, that might not burn as much Ether as if we have a very high base fee and a fairly small tip. So it's a bit more complex than just saying that 1559 will make ETH deflationary. So with that being said, let's just look at where things are at right now. So first, if we look at the client implementations, you know, most teams have started their implementations of 1559, and almost all of the ones that have started have implementations that are live on a new testnet, which is only being used for 1559. There's obviously still a lot of open issues on the engineering side, and we have a full list of things that need to be solved that I've linked in the doc. But here are like a couple of the big ones. The first is just large state testing. So right now we have a testnet, but it has a very small state. There's barely any transactions on it. So that doesn't tell us a lot about how 1559 would work on an environment like mainnet. And in order to test this, the Beiko team has built a large state testnet generator, which can create a new network with a very large state and a large number of accounts. So we can see how 1559 works in conditions similar to mainnet. That's one of the things we're currently working on. The second big open issue is transaction pool management. And what the issue is there is that under 1559, it gets much more complicated to sort transactions in the transaction pool, because the base fee changes from block to block. And that means the amount that the miner can receive can actually change as well, whereas now a miner can just sort transactions by gas price and they'll know which ones are the most profitable. So we're looking into different solutions for basically algorithms that can allow us to sort the transaction pool efficiently, even though it's a bit more complicated. The third thing that we're looking at right now is the base fee update rule. So right now, our current base fee update rule is a bit inefficient in that it goes up and down at the same rate. And that means that if you need to process a whole ton of transactions, you'll go up very quickly. But then once you've processed those transactions, you might need to mine a few empty blocks to then get to a spot where you're processed. So yeah, right now with the current update rule, if the base fee is risen super high and you've processed all these high paying transactions, if you wanted to lower again and process kind of the transactions that are in the transaction pool, you might need to mine a couple empty blocks or mostly empty blocks to lower it quickly enough to get back to that equilibrium. So this is not optimal, but it's not a blocker. And then you know, I have my last category, which is everything else. So 1559 touches almost every part of Ethereum clients. So there's a ton of things we need to update. So for example, we need to update JSON RPC specs, tooling, the testing infrastructure and whatnot. So this is, you know, just work that we're slowly working through as we get kind of these other pieces a bit more finalized. Then we've been doing a lot of R&D and simulations for 1559 as well. So the gist of it is to prove that 1559 is actually better than our current status quo or that other alternatives, and to simulate some of these scenarios before we deploy it on public networks. So the first thing, I've mentioned this in the very first slide, was a proper economic analysis of 1559. So Tim Roughgarden has done one. It's over 50 pages long, and it provides really an in-depth view about, you know, why 1559 is good, how does it improve on our current model, and what are some potential issues. Another area of work was doing what I call mechanism comparison. So the biggest one there was done by Hasu and Georgios Konstantopoulos, who've published a comparison of EIP 1559 with another EIP called escalator fees that provided a different approach to manage transaction fees on the network. And it analyzes whether escalator fees are better or worse than 1559 and how they could potentially be used together. Third, on the simulation side, Barnaby Mono and his team from the EF have been working on several simulations looking at how different types of user behaviors could result in different types of outcomes in terms of transactions inclusions under 1559. And finally, the Nethermind team has just started looking at how would legacy and 1559 transactions work side by side on the network? How did they get included in blocks under different conditions and whatnot? So again, a lot of work in progress here. Yeah, and it helps us really understand how 1559 performs both from a theoretical and practical perspective. So in terms of next steps, here's kind of my rough list. You know, it might still change as we get it done. But where we're at right now is we need to finish testing on these large state test nets to make sure that 1559 works as intended, and you know that every kind of small tweak we make to it works in a condition similar to mainnet. Then we need to do another kind of significant change to the spec to add EIP-1559 support, which is an EIP that provides arbitrary transaction types on Ethereum. And we'll be introducing that in Berlin. So once it's done, we'll want to add it to 1559. Then we need to ship Berlin. So this is the other upgrade that all core devs is really focused on right now. So a lot of the kind of core dev bandwidth is spent on that. And Berlin will also be adding a lot of denial of service protections to Ethereum, which are useful for 1559. So once all that is done, we'll need to do a bit of polish work on 1559. So like I mentioned earlier, having some JSON RPC specs, having some better guides for the community to test out 1559 and add it to their tooling, having some more open test nets that we invite people in, and potentially having a bug bounty on the spec. And then as we're doing that in parallel, we'll be moving 1559 through the all core devs process, which will lead all of the client teams to finalize their implementations, which should give us, some ephemeral test nets in conjunctions with other EIPs like we've seen for Berlin. And once that's done, we'll push it to the test nets. So Ropsten, Rinkeby, Gordy, and whatnot. And assuming everything goes right, then it would be deployed on mainnet. And again, all of this is assuming we don't have anything going majorly wrong along the way. And that's what I had. I'm happy to take some questions.
Okay, great. Whoa, excuse me there. Dragan, I'd like to give you a chance first if there's any questions, like, as a open Ethereum developer, if there's anything in particular you wanted to ask, just like to give you the chance here.
Thank you, but I'm mostly here for information. Overview of 1559, and I think it's a great presentation. Thank you.
Okay, cool. Just as an opening question, so you had a nice slide there with some of the major studies that have been done on 1559. Tim Roughgarden, Hasu. How has 1559 evolved since the initial proposal? Like, what unexpected discoveries have you discovered, I guess, about the Ethereum protocol itself, or what effects 1559 would have on the chain over the course of the implementation up to now?
So I think the biggest takeaway is how little has had to change. So I think that there's kind of a slope of understanding 1559 where, like, it sounds like a really good idea at first, then you start understanding better, and there's like all these weird quirks about it, and they sound like pretty bad ideas. And then you understand why they're actually there, and it's, it's actually kind of the least worst design we can get. And it's weird that you have to couple, for example, burning the base fee with a UX improvement, but all those things are actually needed with one another. So that's, I think, my biggest takeaway is how little kind of the general design has had to change, and how, I guess, expensive or burdensome other changes are to do. So, like, for example, adding escalator fees adds a lot of complexity, but doesn't provide that much value. So yeah, I guess my biggest takeaway is how kind of sound the initial mechanism is, despite it not necessarily appearing that way. And in terms of specific changes, I mentioned the update rule is something we'll look at changing. So there's a bunch of like small parameters we can update and change. For example, the original 1559 spec wanted to have blocks up to 300% full rather than 200%. So small things like that have changed, but the core of the mechanism is still the same.
Interesting. About the mining algorithms also. So I guess this is probably more of a general client question. You mentioned that these days for a miner to sift through the pool, they basically can just look for places where the gas being paid by the submitted transaction is higher, and they'll understand that it's more profitable for them to mine that transaction. But that with 1559, you end up with sort of a different outlook, because if they're going to have to burn, actually, I don't know if I'm going to say this right. I think I'm probably going to say this a little bit wrong, so just correct me on the parts of this that I say wrong. But it may become more profitable for them to delay mining a transaction with a higher tip. Is that correct?
No. So it wouldn't be profitable for them to delay mining, but it'll be more computationally expensive to sort the transaction pool in a way that shows them the most profitable transactions. So what, I guess there's a few outcomes that can result from that. First, maybe they put suboptimal transactions in their block. So that means that, like, they could have filled the block with, a better set of transactions that would have generated more money. And we're aiming to avoid that. But the second thing that's worth, I guess, thinking through under 1559 is, because you kind of always have extra room for transactions, because you can stretch the blocks up to 200%, the transaction pool will be much emptier than it is right now most of the time. So miners actually have an incentive to include transactions as quickly as possible, given how little there are in the pool, and that if they wait too long, then the next miner of the next block will be including them. So it's really just about finding a better way to sort the transaction pool. Yeah, that's a big challenge.
So actually, I would like to dive a little bit more into this, just because well, actually, just to be blunt, just because I'm not getting it. So what makes it harder to sort? I think there's a point here that I'm missing, because I would have thought that you could have just looked for the highest tip, but
no,
it sounds
because
like that's not right.
no, it's not the, oh, that's the wrong, let me pull it. Is this, no. Sorry, I can't find the hack MVD, but there's a write-up about this. I'll try to share it afterwards. But the gist of it is that because
we can put it in the comment, like we can put it in the with the video, no problem.
Yeah, it's that because you set a fee cap and a tip, if the base fee rises, and it rises more, if the base fee rises and your fee cap is close to the base fee, it'll start eating into your tip. So for example, if your fee cap is 10, the base fee is 5, and your tip is 4, you know, that means that you kind of have a budget of 6 gwei for your base fee before it starts eating to the tip. So if the base fee then goes up to 7, instead of your tip being 4, it'll lower to 3. And then if it goes to 8, instead of it being 3, it'll lower to 2. So as the base fee increases, it can lower the tip that a miner will get. And that means that the miner basically, the naive way would have to resort the transaction pool every block based on the base fee value to see what's the tip that they're getting. And there's a couple of heuristics that you can use to minimize that sorting, and that's what we're looking at right now.
So the algorithm still is, it is actually just going to sort of rebase after each block and calculate.
So ideally, ideally you don't want the rebase after each block, because it's just a lot of, it's just too computationally expensive to do that. So if you can come with heuristics about which transactions are likely or unlikely to change between 2 blocks, and not sort those, but just sort the subset that have changed, then you save a lot on the sorting. But that's like the gist of it. It's just like, because the base fee moves, that can lower the effective tip, and you need to find out which transactions have had their tip changed. And how do you resort them efficiently compared to all the other transactions in your transaction pool?
Interesting. Okay. When we take a look at the 1559 model, so the base fee plus tips during congestion, should those prices be lower than the gas prices we're seeing in congestion now? I mean, obviously, this is going to take a certain level of projection and estimation. But so is there a guess?
I think they'll be slightly lower, and by slightly, think 10%, not 10x. And the reason for that is that because during congestion you can double the block size, it means it takes you less blocks to process all those transactions, and transactions are paying kind of like a lower base fee. Because it's just spread across a fewer number of increases. And then because you've processed twice as many transactions, that spike only lasts for half, the amount of blocks, and then the fees start falling again. So it'll impact it a little bit, but not a ton. In his paper, Tim Roughgarden has a table that shows, kind of mathematically what the difference would be if you had a spike in demand under 1559 in our current model. The gist of it, it makes it short, a small impact, but it doesn't. If you have more demand than there is supply on the network, you're always going to see a massive increase in fees.
Interesting. And it could be I should have asked this before, but you mentioned during the presentation that one of the advantages is that right now the amount of gas that users are willing to pay for transactions involves a lot of overbidding, or maybe just in slightly more technical language, since it's a first price auction, users are overbidding often. Could you describe that a bit more, like how we know that users are overbidding right now?
Yeah, and I'll take, again, I'll steal from Tim Roughgarden's paper here. The way he describes it is like the difference between buying a house and buying something on Amazon. When you pay for a transaction fee on Ethereum right now, it's the similar experience of buying a house, right? You don't know how much other people are bidding for the house. You don't know how much you're going to pay for the house until you know whether your bid has been accepted or not. And once you paid for the house, at least on Ethereum, you get to see what other people have paid and whether you kind of overpaid or underpaid. So there's just like a lot of uncertainty in that, which leads people, if they really want to be included, to like overbid. Just like if you wanted to buy a house you really like, you know, you might overbid relative to the house's value. And under 1559, because we have the base fee in the block header, it's more like buying on Amazon, where the block header gives you a price. It says, you know, this is the price to be included in the block, and you either take it or you leave it. So that when you're paying, you can quickly estimate, you know, this is the price I should pay. And if you don't want to pay it, then you just don't send your transaction. But if you want to pay it, you don't really have to pay more than that because the price is there in the block header. And the only exception to that is when you have these periods of like very high congestions. So if the blocks are completely full, then we basically revert to a first price auction on the tip, where people are going to be overbidding each other on the tip. And that's kind of this is a scenario that might happen, say, 1% of the time after 1559, but it's the scenario we're in 100% of the time right now.
Mm-hmm. Cool. One side question that I have to admit, like, really piqued my curiosity. Going through the Tim Roughgarden report, I was really struck by how proficiently he could talk about Ethereum on the protocol level. Do you have any insight into how he got that proficient in Ethereum? I'm assuming just because of 1559.
I think he had one or two papers on like fee markets and blocks before, so he was definitely familiar with it.
He was already okay. I thought 1559 was his first foray into Ethereum. I was like, wow.
No. And I mean, he spent a bunch of time for 1559 specifically talking with the teams working on it, the researchers, and whatnot to make sure he understood it well. But he had some prior experience in, I'm pretty sure Ethereum, but definitely Bitcoin at the very least.
Okay, cool. Thanks.
So talking about the next steps, I see there are some next steps that you have mentioned in your slides. Can we get in terms of timeline when we can expect the shipping of V1 in terms of like month or year? Anything rough?
It's really hard to make timeline predictions because it's so dependent on things like Berlin or whatnot. What I've been
I was going to say, let's figure out what we're putting in Berlin first.
Yeah. What I'm aiming for is the fork after Berlin. And again, this is not like dependent on me, right? Like it could not happen. And then historically, you know, forks on Ethereum have been between like 6 and 12 months. I'm hoping we can get closer to 6 months for this. So if Berlin goes out, you know, in like January or February, then I suspect like my hope would be somewhere in the summer to see 1559, but this is assuming everything goes right, assuming there's no major delays and whatnot. So I don't want people to like assume that it'll go live in the summer, but I think that's kind of the optimistic timeline.
If I could follow that up, I don't know where we're holding right now about 2929 and that sort of.
It's included in Berlin.
But what else is coming in with it? I would say
in Berlin,
out of that whole package. Like, is it also 2913, 2930, 20?
Yes.
Oh, I can't remember the whole package.
We have EIP 2929 in Berlin, which is a gas cost change that helps protect against denial of service attacks. Mm-hmm. The problem with gas cost change is they break smart contracts that rely on them. So we have EIP 2930 that helps address that. So it gives you a way to, if you specify the parts of the state that you're accessing in your transaction in advance, you can kind of pay the old gas costs and not have your contract broken. So it gives you a workaround. The challenge with 2930.
Then there was 2972 on top of that also is to protect against certain kinds of contract breakage, no?
No, that's a bit different. So the thing with 2930 is it changes the transaction format. And so in order to be able to have different transaction formats on each one, we can do two things, right? Either we can just hard code two different transaction formats, but that kind of gets ugly when you think about having a third one or a fourth one, and 1559 wants to introduce another one. Account abstraction wants to introduce more. So we have this other EIP 2718, which allows us to have arbitrary transaction formats. Okay. And so because we had 2930, which changes the transaction format going into Berlin, we decided to also have 2718 right now to only support the 2930 type transactions, but in the future, it'll support different types of transactions as well.
And 2718 is also going into Berlin?
Yes.
Okay, fine. Then I guess out of that whole bulk, the one thing I'd be left with is SSZ, because there was talk about SSZ.
So
also
SSZ encoding is, it's what ETH2 uses. And it's like, I'm not extremely familiar with the detail of it, but it's like a more efficient encoding scheme than RLP. But it's a ton of work to change because basically everything in the clients is encoded. So we're not doing that for Berlin. And it's also a pretty significant change. So if you change how like all the data is kind of encoded in the clients, there's a lot of opportunities for bugs. So one idea that the Get team had was to first start by changing SSZ or changing RLP for SSZ at the networking layer. And the reason for that is that the networking clients support multiple protocols. So they could support both the RLP and the SSZ version. And so if there's a bug in SSZ, it's not the end of the world. You can just keep using RLP. Whereas at the consensus level, we don't have that freedom. Like once we make a consensus change, everybody has to do it exactly at the same time, and there can't be bugs. So I think, I'm personally in favor of just going in that kind of more incremental approach where we can see it working well on the networking side, which is not consensus critical. And once that's kind of done and tested, then we can look at bringing it into the consensus level.
Which would also mean, this is sort of what I was going to drive at, that we wouldn't have some kind of like behemoth hard fork with like full SSZ transition and 1559 coming out in the same fork.
I don't think so. Yeah.
Uh-huh.
Yeah.
I hope not.
Yeah. It's hard. It's hard to predict these things, but I don't think so. I think we might do something like, I don't know, SSZ networking in parallel to 1559 or whatever, but I doubt we'll do SSZ consensus at the same time as 1559.
Yeah, that should be more possible.
Yeah. Okay.
So we know that this 1559 proposal is also implemented in Filecoin. So my question is like how difficult or how easy it is, the implementation is in Ethereum chain in comparison to other projects.
Yeah, there's a bunch of projects that use 1559 now. And so it's been really useful to see that it works. I think there's two things that Ethereum that makes it more complicated. The first is we really care about having nodes be easy to run. And easy, like obviously a spectrum, but like easier than some other projects which don't mind a bit more centralization for their nodes. And what this means is then things like having the 200% full blocks are a bit harder to introduce on Ethereum because we want to be sure that even kind of the smaller nodes on the network are able to handle that, and that's like a main concern. The other big challenge with 1559 on Ethereum is the network is already live and changing into that. So a lot, if not all of these networks that have implemented 1559, they've implemented it since the start of the network. So it's not like they have a transition to think about and making sure that things don't break because it's always been that way. And that's another thing that's like a big kind of area of concern in 1559 that we want to get right. And I think kind of related to that, a third thing is just like any change in Ethereum, because it affects a live network of, I don't know how many $1 billion now, is going to take longer to roll out than a change in a newer network that doesn't have as much value and as much contracts at stake.
Right. So yeah, that was like one important thing because something going on Ethereum is like a bigger value of cost.
Yeah.
So, talking about that, and I would also like to bring the outreach thing that was done, like reaching out to project and other infrastructure providers in the beginning. The idea was to like let them know, make them aware, and get the implementation on time. Now that this thing is there in the proposal that we can also support legacy transaction, how much effect it's going to make on a simple user in case their wallet is not using that 1559 transaction.
Yeah. So anyone will be able to send a transaction with a legacy wallet, or even if you had already signed a transaction before 1559, you want to send it after, that'll be fine. The only downside is it might just cost you more gas. So it won't be as gas efficient as 1559 style transactions. And there's ways, I guess, if you wanted your legacy transactions to be as gas efficient, there's ways you could do it, but they're very kind of complicated. And at that point, it's probably just easier to use a 1559 transaction. But there's no transaction that was previously valid that would become invalid after 1559.
That makes sense. And I think that's going to be really helpful for people who somehow missed it, like, not aware of it.
Yeah,
So
absolutely. Yeah.
it's a wonderful step.
Yeah.
Dragon, do you have any further questions on technical part?
Yeah, when we are point of using old section and new pool, is there any plan to basically transition from the old pool to the new pool? How that path is going to happen?
So by pool, you mean transaction pool, right?
Yeah, yeah.
So right now, there's only one transaction pool. 1559 and legacy transactions will be in the same transaction pool. So we don't need to keep them separated. What we do is at the client level, we interpret the legacy transactions as though they were 1559 style transactions with specific conditions, like at the bottom of the slide here. So I don't see, so, we could decide to remove support for legacy transactions, but like that would be, I guess, another hard fork and another EIP. I don't see why we would do that at the very least until the merge of ETH1 to ETH2, because all of the ETH1 clients already support legacy transactions. I think that, if you made an argument like once ETH1 merges into ETH2, maybe you don't want to support legacy transactions and just 1559 because it makes developing new clients easier. Like I can see that, but I personally would not advocate for it before that, especially given that all the code for legacy transactions is already in the clients.
Yeah, that's it.
So one last question that is coming from the theme of the show about the EIP. The present status of the EIP shows that it is in the draft status. I mean, my understanding is now that we are doing a lot of stuff. We are also on the test nets. So is it the right time to move the status to in review, if not to the last call?
I think it would probably make sense to move it to in review. The reason it hasn't been done is just because we've been so busy with other stuff. It's more oversight, but yeah, we can definitely follow up on there and move it to in review. I don't think it makes sense to move it to last call yet. Like I think once it goes through the all core devs process, we probably want to move it to last call. But we're definitely at the spot where like getting review from the community and getting more eyes on it is really valuable.
Great. So that's all from question point of view. I hope that today's episode will be really helpful for our community who are new to the proposal and wanted to have a quick summary. We also touched on some of the good and a little technical questions that are useful for on-chain projects and wallet and other infrastructure providers. So as we see this proposal, this may have at least 6 months from now for getting onto the mainnet. So the cat herders may schedule another episode on PEEPanEIP or maybe a community call for EIP-1559 when it is very close to the upgrade to keep everyone posted about the progress. This proposal can also be followed on Ethereum R&D Discord server. So for people watching us on YouTube, if you like this episode, don't forget to hit like, share, and subscribe Ethereum Cat Herders channels. You may find Twitter handle for today's guest and the presentation link in the description section below. With the help of PEEPanEIP series, we are trying to share information for upcoming EIPs. If you have question, comment, or concern about this or any other proposal, feel free to leave a comment. And if you have suggestions on which proposal we would like to include in the show next, let us know. You can join the Discord of Ethereum Cat Herders. The invite link will be provided below. See you next time with another proposal. Till then, keep sharing your love with Ethereum Cat Herder. This is your host, Pooja Ranjan, signing off. Cheers. Thank you, Tim. Thank you, Dragon.
Thanks.
Yeah,
this
great
was great.
stuff.